Okay, welcome to the fifth lesson of the Unit 3 on adding polynomials and subtracting polynomials. If this seems like a review of stuff that you've done in Algebra 1, that's probably because it is. It's just getting a little bit more challenging as far as number of terms and different situations. So let's just go through it. You could add these in a couple of different ways. The first one, they show it in a vertical arrangement where they put the first polynomial up here. Now the one thing to really watch for is make sure that you have like terms grouped together, and usually I like to make sure that they go in descending order. Not that you would have to, but it really reduces the chance of error. So the exponents is x to the third, x to the second, x to the first, and then that would be x to the 0th because it's a constant. Now on the next ones, we're adding them. So we just line up with the like terms. So the x squared goes here, the x goes here, and the constant goes there. You just add the numbers. 3 and nothing makes 3x cubed. 12 and 5 is 17x squared. Now one thing that I will see sometimes is students get confused and think they should add the exponent. You only add the exponent when you multiply. 9 minus 6 is 3, and 6 plus 7 is 13. Okay, so that's one way that you can do these. The next way is, again, adding, and you want to add your like terms. So this time they're going to show it in a horizontal format. Again, it's suggested you put it in descending order, just simply so that you don't have as high chance of error. So we have x squared as our first term, and here we have an x squared. So we would add those two together. Horizontally, we just group them together. Next, we have a 2x, and we have a minus 2x. So even though we're adding them, you have to bring in the negative, just like you did up here on the negative 6x. And then finally, the constant term is a 1. So negative 7x plus 1x, that would be a negative 6x squared. Sorry, I should be saying squared. 2x minus 2x is 0x, and then we have a 1 on the end. This can be wiped out, so we have a negative 6x squared plus 1. Okay? Do you get the same results whether you add polynomials vertically or horizontally? Absolutely. It doesn't matter which way you do it, it's which way is most comfortable, and it results in the same answer as long as you haven't made a mistake. So you should fill that in. 1b says, is the sum of two polynomials always another polynomial? And the answer would be yes, absolutely. The two add-ins consist of a sum of monomials, and after adding other monomials, the result is always going to consist of the sum of monomials, which is a polynomial by definition. The last one down here is the sum of two polynomials of fifth degree, always a polynomial of fifth degree. Give an example to explain your answer. Well, fifth degree means it could be anything in that leading coefficient or leading term where the exponents add up to 5, but I'll just use x to the fifth. And let's see, if we had 6x to the fifth, is there any way for us to end up without an x to the fifth there? What could you add there that would cause it to zero out and not have an x to the fifth? If you said negative 6x squared, that would be correct. That's a great example of when it wouldn't always come out to be a fifth degree. So the answer is no, that it won't be fifth degree, and then you give your own example. I would be looking forward to seeing that. Okay, next we want to subtract polynomials. And here, the main thing is we want to make sure that my suggestion is that we distribute this negative throughout before we rewrite. So we have 9x squared. Now if we get rid of this negative here, we can just say plus, because we're going to distribute it to each one of these. That would be a positive 6x squared. That would be a positive 2x. And that would be a negative 1. Okay? Now we just simply add them. 9x squared plus 6x squared is 15x squared. 0x plus 2x is 2x. And 2 minus 1 is 1. Next up, they're going to show you this horizontally now. So again, the same thing. I distribute this negative 1 to each of these. Now remember, you only distribute it to the parenthesis that 1 is setting right next to, not to this front parenthesis. So here they show it where they've distributed it to each, and now you simply put them together. So 6x cubed minus 4x cubed would end up being 2x cubed. 3x squared minus 8x squared would end up being a negative 5x squared. 2x plus 2x would result in 4x. And 9 minus 5 is 4. So there's two different ways that you can do it. In either case, you need to show that you distribute that negative. It can be done just remembering that you're subtracting, but I always see a high rate of error. So please show that you're distributing the negative, whether you do it vertically or horizontally. Let's go through these reflect questions. Again, I'm not filling these in. You can fill them in as I explain them. How is subtracting polynomials similar to subtracting integers? Well, when you subtract integers by adding the opposite, for example, 3 minus 3 is the same thing as 3 plus a negative 3. Okay? And so it's the same thing. We just change the sign and add, and we come out with the same answer as if you were to subtract. We just like to think of it as adding the opposite in these cases. In part A, you have a gap in the polynomial 9x squared plus 2. Right up here. Right there. There's a gap there. We should have an x term, because we have an x term down below. When you write the subtraction problem vertical, why do you have to have the gap? It's a placeholder, basically. It's in order to hold that place so you can line that 2x up with the nothing. Is the difference of two polynomials always going to be a polynomial? Yes, it really will be. It's the equivalent of finding the sum of the first polynomial and the opposite of the second polynomial. And so really it's the sum of two polynomials. So if you think of an example that would break that, then please bring it to class. We'd love to know the thinking. Okay. Here is a modeling page. We love the modeling. According to the data of the U.S. Census Bureau for the period of 2000-2007, the number of male students enrolled in high school in the United States can be approximated by the function mx and that function, where x is the number of years, so x, number of years since 2000, and mx, number of male students in millions. Okay. The number of female students enrolled in the high school in the United States is approximated by that function, where x is the number of years since 2000, and f of x is the number of females in millions. Estimate the total number of students enrolled in high school. Okay, so we know that simply we need to add the number of males to the number of females. Okay, so if we add these together, we end up getting 6 and 4 is 10. 0.010 negative. Add these together, 7 and 9 is 16. Carry the 1, 3 and 3 is 6, 0, 0.066 x squared. Add these together, 5 and 9 is 14, 4 and 6 is 10, plus 1 is 11, and 1 and 1 is 2, so 0.214 x, and now we have 8, 7, and 15. Okay, so now they want us to write it just as the total polynomial. So this is the total number of students, and we would have negative 0.01 as you round that off, x cubed, plus 0.066 x squared, plus 0.214 x, plus 15.78. Okay? That's just cleaning it up a little bit, getting rid of the excessive zeros. To evaluate t to the x for 2007, well, we use x equals 7 because it's 7 years since the year 2000, which is what these are based on. And we simply plug in the 7 for that x value. I would suggest using a calculator, but you don't have to. You will come out with T7 equaling 17.1. Don't forget that this is in millions of students, so it's actually 17,100,000 high school students in 2007. So, is it possible to solve this problem without adding the polynomials? Yes. You could estimate number of males and females separately for the year 2007 and then add the answer. It should come out the same. And then the other question there is explain how you can use the given information to estimate how many more male high school students than female high school students there were in the United States in 2007. Well, if you can use the male polynomial, this one, to represent the number of males, and simply plug in the 7 for the x value and evaluate that, get your number, and then take your polynomial for females, plug in 7 as well for the x, and then in finding the difference, you would be able to see how many more males there are than females. Okay? So that should bring us right up to the practice problems. And I will see you in class. In class, we'll be doing these practice problems. If you don't happen to make it to class, then you need to schedule tutor time to come in and go through these practice problems with me. I need to see how well you understand the concept. It's not just about doing this page. It's about making sure that I see how well you understand it and making sure that you really do understand it. So please come by and see me, do some of the problems with me at least. Thank you very much. Have a good day.